Hey everyone, I'm your host, Dr. Marie McNeely, and this is episode 625 of the People Behind the Science podcast. This week, we are excited to reshare our interview with Dr. Nancy Mills, originally published on December 1st of 2014. Listeners, Nancy is an organic chemist, educator, and leader within the chemistry community. In her research, she has created and studied a rare unstable, or anti-aromatic, compound that does not turn into a stable one. She has received numerous awards for her excellence in teaching, and she has contributed to improving chemistry curricula, mentorship, and career development for early career chemists. And in our interview, Nancy shared more about her life and her experiences in science. So we hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. I am delighted to be here today with Dr. Nancy Mills. So great to chat with you today, Nancy. How are you doing?
I'm doing great. Thanks much, Marie.
Wonderful. Well, I am delighted to be here with you today, like I said. And listeners, Nancy is a professor of chemistry at Trinity University. She received her PhD in chemistry from the University of Arizona, and she spent a few years teaching at Carleton College before joining the faculty at Trinity. Now, Nancy has received many awards and honors during her career, including selection as a Council on Undergraduate Research Fellow, Distinguished Achievement Award in Scholarship from Trinity University, the American Chemical Society Award for Research at an Undergraduate Institution, and the Piper Professor Statewide Teaching Award, as well as election as a Fellow of the American Chemical Society and a Fellow of the American Association for the Advancement of Science. Nancy was also named a Z.T. Scott Fellow at Trinity in recognition of teaching. Now, Nancy is here with us today to tell us all about her journey through life and science. So today, Nancy, we are thrilled to get to know you, both as a scientist, but also as a person. So can you take a few minutes to tell us what you like to do with your time when you're not doing science?
Well, I'd love to. I really do enjoy the science. And in some senses, doing the science is almost as a hobby of mine, as well as my job. But I also like to read. I like mysteries and have tried to write the perfect crime. Unfortunately, I think that I have figured out the perfect crime, which doesn't make a very good idea of a mystery if you want it to be solved.
Right.
But I'm still working on that. I also enjoy cooking, and one of the things that I would suggest that our listeners might think about is the Cook's Illustrated series of cookbooks has a book called The Science of Cooking, and it has a bunch of wonderful recipes, but it also tells the science behind the cooking. So if you ever wondered whether it was necessary to sear meat to make it juicy, they've done the experiment. So that's a lot of fun.
Oh, wow.
And then the final thing that I like to do is my husband and I are both ultralight backpackers, which means that the backpack that when I was 20 weighed 35 pounds is now down to about 12 to 15 pounds, which allows us to continue to do a lot of backpacking as we move toward our older years.
Well, that is wonderful. Nancy, you have so many fantastic hobbies. I don't know where to start. I love to hear that you're excited about cooking. It is chemistry in the kitchen after all, right?
Absolutely.
And great to hear that you're able to enjoy the great outdoors, doing this ultralight backpacking. I think that must be a challenge. I mean, going from 35 pounds down to 12, what is your secret?
Very light material, using a hammock instead of a tent, and using a Kindle instead of taking 4 or 5 books.
Ah, all good secrets. I like that. So on the topic of books, you mentioned one of these cookbooks that you recommend. And I always like to ask the researchers that we feature on our show if they have a favorite book or one of these memorable books that they've read that they can really recommend to our listeners as well. So is there another one on your list?
I have a favorite book, but it's not a cookbook. And the book that I would recommend that people look at, particularly females who are thinking about science, is a book called Why So Slow by Virginia Valian. And it asks the question, after so many decades of affirmative action, why is it that there are so few women at advanced levels? And I think that it's important for both women and men to recognize the sorts of prejudices that we unconsciously carry with us as we look at the activities of men and women. So that's a more somber note, but I think it's a good book to give people a reality check.
Certainly. Well, great recommendation. And we'll put that out on our website for our listeners to check out there if they want to look it up and pick up that book. That sounds wonderful. Now, Nancy, we talked a little bit about how you like to spend your time outside of work. I'm curious to hear how you describe now what you do to someone who's not at science, what you do when you're at work.
Well, I need to begin that by first of all describing what at work means for me. I'm at an undergraduate institution. There are no graduate students, no graduate programs in the sciences. There are only 3 graduate programs at my school that's about 2,500 students. So the research that I'm going to describe is research that was done by 18 to 22-year-olds working for 10 weeks in the summer for the most part. People, when I began to teach, felt that it was so challenging to do research at an undergraduate institution that you couldn't expect that very much of any import came from that. And that was part of the reason for the founding of the Council on Undergraduate Research. And so I think that I've been fortunate to be able to work in this kind of an environment with the support of a lot of my colleagues to demonstrate that we can do good stuff here with inexperienced students. So what do I do? Well, briefly, I'm an organic chemist, and what an organic chemist does is to make things. Organic chemists make drugs, they make polymers, they make all sorts of things. And in order to decide what sorts of things are possible to make, we really worry a lot about what makes things stable. And one of the most important concepts in organic chemistry that has to do with stability involves the concept of aromaticity, which originally rose from a study of essential oils and spices, but is now bigger than that. And basically, anything that is aromatic has a particular type of stability. And for the longest time, it was not understood why things that had this set of requirements, if you will, were so stable. But then quantum mechanics gave answers to this question of stability and also allowed people to consider a variety of things that by these rules should be stable. But quantum mechanics did another thing, and what it did was it described a set of compounds that should be particularly unstable. Now, for obvious reasons, nobody in their right mind would try to make something that's supposed to be unstable. It's hard enough to make things that are supposed to be stable. So nobody looked in these areas. And I was working now it's about 20 years ago, trying to make a new kind of aromatic molecule. And to make it, what I had to do was to try to make an anti-aromatic compound, these really unstable ones. And then I figured that it would certainly turn into an aromatic compound. Well, it didn't. And that was a real quandary for me because nobody believed that one could ever make and characterize something that was anti-aromatic, that was unstable. And here I'm a person at an undergraduate place working with undergraduates. And I think I've made this thing. I mean, no way.
That must have been an exciting day, certainly.
Yeah, well, what I had to do was then really work on documenting the properties so that it was impossible to disagree. And so when I finally did enough work to convince myself and others, I was able to publish it in the Journal of the American Chemical Society as a communication, which is one of the hardest types of articles to get published. So it was really wonderful. And I lucked out so much in being given this mistake that turned into a wonderful research area.
Certainly. Well, that is a fascinating topic to be studying, and really, I think, a challenge for you to think of these different research projects, things that lend themselves to those little 10-week type stints with undergraduate students. So really, really interesting that it's sort of a completely different environment from, a lot of the people that I've been chatting with, which is fantastic. Now, with all the work that you're doing and all the other wonderful things that you love to do outside of work, can you tell us, Nancy, about what motivates you? Do you have a particular quote or a saying, one that resonates with you and keeps you motivated and focused?
Well, I think that probably the most important quote that guides me is something that my husband keeps saying. And he says, "Remember, the journey is the reward. we tend to get so focused on the outcome that we forget that it's the process that's as important as the outcome. And for me, having children was one of the things that anchored me more completely in the present than in the future. So the journey is the reward.
I love that. And I think that journey is the reward piece applies so well to the process of science, really just the fact that there's so much that goes into it before you finally get maybe that one paper or, that one project completed. So wonderful to sit back, relax, and I think enjoy the journey, not just always be so focused on the final end product that you can't enjoy that time that you're spending. So wonderful motivational quote. Now, can you tell us, Nancy, about some of the people along your journey, along your career, who really motivated or inspired you and served as role models?
When I thought about role models, I realized that I didn't really have any role models. When I was starting out in my scientific career, there were no female faculty in chemistry. There were no female faculty in the sciences as a whole. As I was an undergrad, there were fewer when I was a graduate student. And then when I took my position at Trinity, there were no female faculty at all in the sciences. So if you think about a role model as someone who serves as a model for what you can do, I didn't have any role models, but what I did have were wonderful mentors. And I think a mentor is a person who convinces you that you can do things that you wouldn't have thought that you could do. A person who encourages you to try things that you would have said, well, no, not me.
Right, of course not. Yeah.
Exactly. So when I was an undergrad, Gene Wubbles at Carleton College, which is where I got my bachelor's degree, selected me to do research. And he had to tell me that I needed to do research because I certainly didn't think that that was something I could aspire to. And so that made me think about this as a career. And then when I was at Trinity, Mike Doyle kept broadening my horizons, I guess, in terms of what I could think of. If one grant was good, 2 grants were better.
Right.
So throughout my career, I've had a number of people who've given me that bigger sense of myself. And I think that one of the things that we always need to remember is the importance of mentoring, that people don't always see their potential in the way that they should. And so mentoring is such an important component of our lives.
Absolutely. Well, Nancy, I love that. I love that description of how mentors really push you almost outside your comfort zone, push you to do things that you never really thought you would be able to do or that you never really thought of as an option to do. So fantastic to hear about some of these mentors who really had an effect on your life and your career. Now, can you take us back to the very beginning? I mean, you mentioned you didn't really have a particular role model to look up to as you pursued this career in chemistry. Can you tell us how this interest in chemistry began? Tell us about your early days and maybe hit some of these key points along your journey that really got you to where you are today.
Well, usually when you talk to a scientist about what they did, they were kids who always wanted to pour chemicals together or do all sorts of things like that. And I really didn't. I didn't have a chemistry set. Well, I had my dad's old chemistry set, but most of the chemicals were dead. So that wasn't very interesting. I just tended to do kind of girl things, I guess. But when I went away to college, I decided that I wanted to be a scientist, and I decided I wanted to be a chemist, primarily because I thought that chemists were smart. And if I was a chemist, then I would be considered smart. That was really the motivation for that. And because I was not absolutely certain I had any talent in this area, I also started an American Studies major because I thought I better have a plan B just in case I come to this chemistry course that nukes me. And I think I never came to that point. And so I kind of think that in some senses that feeling that I might not be good enough has helped me be a better teacher because I understand insecurity. It was not always easy for me, so I can understand when it's not for others. So the question then becomes, if I wasn't certain that I would ever have the ability to be a chemist, how did I become a chemist? And that happened through graduate school. And it was just revolutionary for me to be in graduate school where the only thing I was doing was chemistry, because all of a sudden I saw connections between everything, and it was just exciting to go to school every day and see how the pieces fit together. So that's, I think, what turned me into a chemist.
Well, that is a wonderful story, Nancy. I love this description of this almost transformational experience in graduate school. Maybe even better because you didn't have that backup plan anymore. Throw American Studies out the door. You are doing chemistry right now. You are going to make this work.
Right.
So that is a wonderful, wonderful story and great to hear about your journey. Now, we talked about some of the compounds that you work with in your lab today. Can you talk about in detail a little bit more one of these projects that you're working on?
Well, yeah, I would love to. And when I began this process of making these anti-aromatic compounds, all I really wanted to do in the beginning was just to make enough of the compounds to show that they really could be made. They were much more stable than one thought. But at some point in time, you can't just keep making things.
Right.
They have to be worth something. And so then I thought, what is it these things are good for? And so what we're looking at right now is how they allow us to study the movement of electrons. And so briefly, here's the deal. The compounds that we're making are charged compounds. They're cations and they're anions. And compounds that have charges want to disperse that charge, want to move electrons around so that the charge gets spread out. But compounds that are anti-aromatic don't want to spread electrons around. The more effectively they spread their electrons around, the more anti-aromatic they become and the less stable. So I'm working with compounds that have these tensions. They have the need of the charge to spread, the need of the anti-aromatic species to not spread. And what that actually does, we think, is to give us a handle on understanding why electrons behave the way that they do. It's sort of like if we put them in a situation that they don't want to be in, we can look more closely at the factors that make them behave the way they do, if that makes any sort of sense.
Yeah, certainly. Well, that is a fascinating project and really interesting that you're able to use these relatively new compounds to then study something as basic as how electrons are behaving. I think that's fascinating. So wonderful, wonderful project that you're working on. And I think so far we've talked about a lot of the great aspects of your career, working with students, some of these amazing projects that you're working on and your journey to become a scientist. And we haven't yet gone into detail too much on some of the struggles that you've encountered. And I think every scientist has periods that they can look back on in their career, maybe days, months, even longer, where it just seemed like everything was going wrong. And you have these major struggles or major failures, perhaps. So can you tell us about one of yours and how you recovered from it?
Well, I think when I think about my career, the biggest struggle, the biggest problem that I had was one that I've actually already described, which is the trying to make a compound that turned out to be the type of compound that people didn't believe in. First of all, I had to convince myself that I was right. And then I had to figure out how many ways to make other people believe in that. So we worked for probably 4 years before I had enough confidence to try to publish this stuff because I needed to cross every T and dot every I in this. I needed to do every experiment that I could possibly think of so that I could be convincing. So that was the period of time when I was thinking, I can't really keep spending time on this project because if I can't really convince people, then I just wasted a lot of my time and more importantly, a lot of time of my students. So that was a fallow period that actually reaped great rewards.
Certainly. Well, it's very interesting when you're talking about the story, just you're conveying these feelings of insecurity, these feelings of self-doubt. When you get this finding and you're thinking, well, this can't possibly be right. Or if this is right, we need to do a lot more testing just to make sure.
Exactly.
And I think that is something a lot of scientists go through when you get one of these new, almost breakthrough discoveries. You want to shout it out to the world, but at the same time, you're sort of almost that feeling of paranoia, like, well, let me double check everything one more time.
Right. And I also think that there's a difference in the way that men and women do science. And I don't want to overemphasize that difference, but I think that women tend to feel less confident as a rule, or at least women used to feel less confident in their ability to do science. And so they would do more experiments, publish more slowly than sometimes male colleagues would because they just really weren't quite certain that they were seeing this right. I think that that is something that's changing. When I look at my young female students, they seem to be every bit as confident as my young male students are. So I think that that's been a change in the world, but I think there still are sometimes some remnants of that insecurity.
Well, thank you so much for sharing one of these challenging times, one of these difficult struggles that you were having, not only with yourself, but also exhaustively exploring all these different experimental options you could possibly do. I think that is a great way to go about it. And certainly, the data doesn't lie. Once you've tested it every other way, this is just how it is, right?
Yeah, and that's actually the blessing of science, is that the interpretation might be wrong, but if the data is good, it's truth.
Absolutely. Well, we don't just want to talk about these tough times or these struggles, Nancy. Can you tell us next about one of your success stories from your lab? And this can be a big success or even just one of these little victories along the way.
Well, I think for me right now, and I'm in my last year of teaching, I'll be retiring next June. And so what I'm seeing is that I am more capable of doing synthetic chemistry, of having an instinct about synthetic chemistry than I ever thought I would be. And my students are much more capable in doing really sophisticated chemistry. So I have students who are working with materials that catch fire if they touch water.
That must be a little scary. Yeah.
Oh, yeah. The first time that their syringe catches on fire at the end is kind of exciting. But they're much more capable of doing this kind of work than one would have thought, I think. And so I think that my recent successes would just be in the category of recognizing how capable both the people I work with and how I have become in this area.
That must be wonderful, Nancy, to reflect now on your career, on your teaching, all these students who you've influenced and mentored and taught these sort of basic research skills from the ground level so that they can go on and many of them pursue careers in research. I think that is a fantastic success. Now, I know in addition to the wonderful opportunities you have to work with students, to do amazing research, scientists also get quite a few opportunities to travel. So this might be training opportunities or to go to conferences, things like that. Can you think back, Nancy, on all these places that you have traveled for science and tell us about your favorite? Where were you and what made it so special?
Well, it was actually not necessarily the place, but rather the time. And when I first was a faculty member and started going to American Chemical Society meetings, those meetings were the most wonderful meetings in the world because it seemed as though every talk I went to had some kind of relevance to the research that I was thinking about. I sort of felt that how is it that they don't recognize that they can apply this idea in the work that I'm doing? When you think about what makes science work, transformative science is science that started in one area and then is applied in a new area. And that's where the real key discoveries are made. The only way that you see those other areas is when you travel to conferences and listen to talks. And the only way that the connections get made are because every scientist's set of experiences are different from everybody else's. And so they see the world slightly differently, and they see connections that other people might not make. And so that's why I think that the talks that I went to in the early part of my career were particularly transformative. Now, it didn't hurt that some of them were in Hawaii. And I must say that I quite understand at that point why there were so few people in the audience.
Certainly.
But the talks were great.
Right. And you were in attendance at every one of them, right?
Exactly.
Well, that is wonderful. I think Hawaii is a great place to really reflect on things, get your ideas to connect. So, and I think you're absolutely right here when you're describing, some of these transformative ideas in science or these transformative experiments or projects in science. I think you're right. It is these opportunities where things are being connected across fields or across different areas within a field. And I think it was such a great opportunity at these conferences to start building those collaborations with people, having these discussions, sharing your research, learning about them, asking a ton of questions. So fantastic to hear about how these experiences early on in your scientific career really had an impact on you. I think that's wonderful. Now, in addition to some of these travel opportunities, I think a lot of scientists really enjoy the people that they get to work with. And we've chatted about your students a little bit throughout this interview. And I think, with these lab groups that you work with over the years, there's just some amazing, creative, and oftentimes very funny people. And a lot of these groups have their own personalities that spring up, maybe with your own lab, or if you look back to your PhD years. And there's just some funny science memories that you can look back and laugh about. So can you share with us today, Nancy, what you would consider maybe one of these quirky traditions that you experienced, or just a funny memory?
Well, I absolutely love my research students. I think I have the best people in the world working with me. And it's important for me to have my research group become a family, because chemistry's hard. When you come to school, come to work in the summer, if it's not fun, then you feel like you might as well be doing something different. So I try to create a feeling of fun in my lab. And so one of the aspects of this would be our Friday fun days.
Oh, I like the sound of that.
I usually have a pretty big research group, most recently between 6 and in this summer it was 15, which is a lot of undergrads. So we have a social chairman, or maybe 2 social chairmen, and they decide the theme of the Friday fun day and also where we're going to go. So we've had plaid day, and we always have tie day, and then we go out for, as you might imagine, Thai food. But the one that they all like the best is pirate day. So we now have in the lab a collection of wigs and daggers and tattoos and sabers, and everyone dresses up like a pirate, including me.
Oh,
and
wow.
we go out in public and have lunch together. But it's just fun. And I like the fact that frequently my group then becomes a unit that plays together after work. It just makes me feel good.
Absolutely. Now, on Pirate Day, do you also talk like a pirate?
You betcha.
Yeah.
Talk a lot. We talk, but that's not really it. But the students speak a lot of their favorite gas, which would be argon.
Yeah.
Things like that.
Chemistry jokes. I can't get enough of those. Well, that is wonderful, Nancy. It sounds like you have really gone to great lengths to make your lab a wonderful, fun place to work. And I know a lot of scientists, you take their research so seriously, but scientists are people. You like to have fun. And it's wonderful to hear about all these different things that scientists do to make their work environment so welcoming for students and welcoming for the people in the lab. So great to hear about these traditions that you have. And I love the name of it, Friday Fun Day. That's fantastic. Well, Nancy, that is a great tradition to have. And in addition to some of these fun traditions that are introduced in different laboratories, I love to chat about the research that you're doing and also the research that you haven't yet had a chance to do. So I love to chat with researchers about their dream questions, these things that they would love to be able to do, but there might be something standing in the way. So whether this is funding or staff or technology or feasibility, what if we took all of those constraints away, Nancy? Can you tell us today, what is one question that you are just dying to know the answer to?
Well, one of the things that's unique about the compounds that I'm working with, I talked a little bit about the motion of electrons, but one of the things is that the compounds that I'm looking at have electrons that tend to be less tightly bound than in most organic compounds. And you should say to me, and so why would I care about that? Well, if you think about metals, metals conduct electricity because their electrons move easily. If you could make an organic compound that had the same kind of properties, what you could do would be to make an organic metal. And that means that just as you can make a polymer that has all sorts of properties that you want, you could make a metal that had all of those properties. You could imagine a window that conducted electricity, or a wire that would melt at a particular temperature and stop conducting, but, at other temperatures would be a conducting species. You could give materials properties that naturally occurring metals don't have. And so if I had enough time and if I were in the right place, it'd be really fun to see whether our species could be used in that kind of a manner, since they are, after all, much more stable than people would have expected.
Very interesting. So have you had these conversations with maybe engineers or material scientists at conferences to talk about these possibilities?
I have indeed, but I'm in no position to be able to do that kind of work. To the next follower.
You can just sort of pass your brilliant ideas on like you're passing a baton there.
Right, exactly.
I love that. Well, that is a fascinating question and certainly an application that I wouldn't necessarily think about for this type of compounds. That's really interesting. Now, can you think back, Nancy, on all of your years in research, all these people that you've worked with, all the mentors that you've had, and can you share with us today what you would consider the best piece of advice you've ever received?
I tend to go back to this question of the journey being the reward as a way of kind of grounding oneself. I think it's really easy to get too tied up in one's research, to want and need to make it succeed. And so I think that the challenge of all of our lives is a challenge of balance. And I think that the journey is the reward kind of helps us remember the balance we need to strive for.
Absolutely. So are there certain things that you've found help you achieve that balance in your life or help you bring that into focus?
I think actually, as I said before, it really, for me, was having kids. There's an immediacy about my son and my daughter's needs that then pulled me away from what I thought was the most important thing in the world, which was the teaching and research, but reminded me that I needed to be thinking about their needs, and then through their needs, I got a much richer world. So the balance for me was really children.
Well, that is wonderful and great to hear that you're able to, through having children, through this experience, not necessarily reevaluate your priorities, but broaden your priorities, broaden your interest in your life experiences. I think that's fantastic. So can you share with our listeners today, Nancy, one last piece of advice or maybe one last piece of inspiration coming directly from you?
Well, as I think back over the things that have made most difference in my professional life, they've been in two areas. The first one is in mentorship. I benefited greatly from having these wonderful mentors who gave me a different sense of myself. And so I think that for young people starting out, one of the things that they should look at carefully is finding a mentor and talking to older colleagues to see who seems to be the one that can help them the most in terms of getting a grip on what they should be doing. And older faculty and older people need to think about the importance of offering mentorship to younger people. So that's the first thing that I would suggest. And the second is, don't forget the benefits of serving. And so I have three things really where that's been important. When I was relatively early in my career, I got involved in the Council on Undergraduate Research at a time when it was a new organization. And basically, any idea that you had that you were willing to work on, they would let you do. So I created a mentor network in the chemistry area. I worked with really smart people, but I was giving to the council and I was getting back so much more in terms of interaction with smart people, the opportunity to do something of benefit. And so I did that for about a decade. And then I became involved in the Committee on Professional Training of the American Chemical Society. And that is a committee that defines the rules for quality chemistry programs. And when I began with that, it was dreadful. What we did was to spend our meetings, our 3 times a year meetings, reading over reports from all of the schools and trying to make sure that they were in compliance with the guidelines. It was just terrible.
Painful.
Exactly. But then in the middle of that time, it became apparent that the guidelines weren't really working for chemistry departments. They were too onerous, that instead of weeding out certain requirements, we just added on more requirements. So what we did then was to step back and say, what should education in chemistry look like, recognizing that there are all sorts of new things happening? How do we balance, the old standards of quality with the new way that the field was going? And that was so incredibly exciting. And I worked with such smart people on that committee, and we came out with some revolutionary guidelines. There was the potential to change the way that chemistry education occurred. And you can't anticipate being able to be involved in something like that And so it was just a gift. It was a real gift. And then the final gift is at my own institution, we got a new president who decided that we needed to do a strategic plan, which was absolutely right because we hadn't done one in the 30 years that I'd been here. And so I got asked to be one of the chairs of that process. And that too was an incredible amount of work. But I got to understand my institution from the vantage point of faculty and staff and students. And we developed a new general education curriculum. It was just really fun to work with these really smart people. So if you give, you get back a whole lot more than you gave is, I think, the message that I would give to people.
Well, I love this piece of advice, and I really love your attitude towards service in these different groups or organizations. I think service is one of those things that I think a lot of faculty members kind of grumble about having to do. They're on so many committees, they're dedicating so much time to this. But like you're describing here, those are some great opportunities to learn more about your institution, to learn from these different colleagues that you're working with, and really to make a change. I think that's fantastic. And wonderful also to hear about mentorship and the importance of mentorship to you and really making that a priority as an experienced scientist to help younger people along their journey as well. So great advice for our listeners today, Nancy. Now, can you tell them how they might be able to reach out to get in touch with you if they want to learn more?
Well, I would encourage them to email me at nmills@trinity.edu. And I'm assuming I'll be able to keep that email address for a period of time after I retire. If not, then I will try to work out some kind of a link so that it goes to my University of Oregon email.
Well, that is wonderful. Listeners, feel free to reach out to Nancy if you have any questions. And Nancy, thank you so much for joining us today and sharing your story.
It was great fun. Thanks for asking me.
Of course. I enjoyed chatting with you. And thanks to our listeners out there. Join us again next time for another episode of People Behind the Science. Your voyage to the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to seeing you next time on People Behind the Science.